I will be summarizing the master thesis by MPavaoMasterThesisOverview entitled Compound Matching for Multiple Ontologies. Integrating and managing data from multiple sources can be a challenge. A strategy may be to link data to ontologies. Ontologies are a representation of a domain using standardized vocabulary where you define concepts, entities, their attributes, and the relationship between these, limiting the ambiguity in concept definition. However, most research areas span multiple domains and topics, which means we need multiple ontologies. So a new challenge is presented: how to reuse and integrate data from multiple ontologies. This is a challenge not only by the size of the ontologies, the complex vocabulary used to define concepts, but also to capture the complex relationship within. In ontology matching, you perform a mapping when you verify if two entities, a label in a source ontology, represent the same concept as a label in a target ontology, as exemplified in Figure 1. A series of mappings leads to the creation of an alignment between ontology classes. There are several ontology matching systems available, to which Agreement Maker and Agreement Maker Lite are quite popular. Compound ontology matching is a much more recent concept introduced by Pesquita's group in 2014 and further extended in the next years. Here you have one source ontology and you map it to at least two target ontologies. And this is the basis of the work for Maria Madalena's thesis in 2019. Here she presents a novel strategy for compound ontology matching using a lexical-based approach within the AML system. Secondarily, Maria Madalena developed a reference compound alignment, a challenge on itself, to evaluate how well her strategy did. The approach is built in two steps. In the first step, she builds a lexicon using the algorithm word sequence lexicon. Here she takes the label from the source ontology and she breaks it down in all words and sequence combination. The lexicon was either built using the words as they appear originally in the label or using the stemming algorithm that reduces words to their root. The second step of the strategy is the actual matching algorithm and the linear search between entries in the lexicon against target ontology labels. As illustrated in Figure 3, you create a series of partial mappings to which you assign a score as given in the equation in the slide. Once you build all partial mappings, the trick here is to choose the highest score mapping as the final mapping between the source label and the target label. The reference alignment was produced within the AML system. Maria Madalena used two source ontologies, the mammalian or the human phenotype ontology, and as target she had 2 or 3 target ontologies. Once she built the reference alignment, she did an automatic evaluation of mapping per alignment. Essentially, she assigned each mapping per alignment to one of 6 categories: equals if the result of the mapping was the same as the reference alignment, contained, different, overlap, or no results. With these, she developed alternative metrics as permissive precision and fuzzy precision as illustrated in the equations, and she also used the classical precision. Overall, if we look at the graphics, we notice that the alternative precision metrics always perform better than the classical precision, while the STEAM algorithm overall improved results. When using the metric recall, the same pattern can be seen, and also in the F-measure metric. To conclude, Maria Madalena explains that the classical metrics have low performance in her strategy because the evaluation is based on incomplete reference alignment. Overall, she was quite satisfied with the performance of the STEAMer algorithm, and the running time of the whole strategy was relatively short compared to other approaches. Last, she presents future work direction. One avenue is to further explore the partial mappings developed during the building of the lexicon. Some of these proved correct compared to the reference alignment, and a human input version could further improve the strategy here developed and presented.